So guys, I wanted to go ahead and then now show you how to write an equation that is in a general form and you write it in a vertex form. So there's a cheat sheet here. This is the question I'm using, example one over here. If you want, you can take a screenshot of that. It's even marked down there. If you want, you can go work it out. Well, let me show you how to break this down so that you can make it uh, what we call a vertex form. So remember, we said the basic things you need to do is to try write this equation or try to approach this equation is something called completing the square. And I told you when you're completing the square, there are some rules that you ought to keep or to follow. So for example, the coefficient of x squared ought to be 1. Meaning in this case scenario, then we have to divide through by 2 so that we can first of all get rid of these 2. You cannot do anything to this equation without first of all getting rid of that 2. Then we can collect like terms. Let the x's stay on the left hand side, let the non-x terms go to the right hand side. So here you're left with x squared minus, this will be 4x is equals to negative 3 all over 2. Now, once your equation is in such a format, the next thing that is easy to do or is required of you to do is to introduce the perfect square. Introduce the perfect square. And this is a value that is a constant. It's supposed to be b all over 2a with a square. So you just need to go and check what is your a, what is your b, blah blah blah, what is your c. So your a here is 1, this is your a. Your b here is negative 4, that is your b. Then your c here, because if we move to the other side, it will have just been positive 3 over 2, but you don't need it in this formula. So just come and substitute the values of a and b. So b is negative 4 all over 2. A is just 1, so it won't have a difference squared. And this becomes negative 2 squared. So this is the perfect square, and you cannot simplify it. You will have to add it onto the equation on both sides with such a manner. So let's go do that to the equation. So the equation is x squared minus 4x is equals to negative 3 over 2 of x. So on the left hand side, I'm going to add here negative 2 squared, and I'm going to do the same on this other side, negative 2 squared. So I told you from the previous video, once you introduce your perfect square, you can easily delete this guy. And once he cancels out, because you're left with x squared plus into brackets negative 2 squared, because now you have two squares, you can complement them and put them under the same square. That will be x minus 2 squared. So once you introduce your perfect square, you can delete the term that carries x, then you can complement the guys. But this is only on the left hand side. If I go on the right hand side, I open the bracket and I simplify this guy so that I can have negative 3 over 2. So this will be plus negative 2 squared, that will be 4. And I can keep going. I can find the LCM here. The LCM here is 2, so this is minus 3 plus 8. So this becomes, if I take minus 3 plus 8, I'm going to get 5 over 2. And you can see I'll be left on this side. This is the right hand side. You can see on that other side, on this side, I'll have x minus 2 squared, and this has to be equal to what? 5 all over 2. And see, it almost looks like the vertex version, it almost looks like this guy over here. So what you ought to do now is to bring the 5/2 back into array. So you're going to have x minus 2, this will be squared, minus 5/2 is equals to 0. Now, remember from the format, you have to have an a in front. It's supposed to be in the form of a into x minus h squared plus k is equals to 0. So this a will usually come from the fraction that will come from the part that was carrying the c. So for instance here, if you multiply through by 5, if you multiply, no, by 2, sorry, by 2, and you multiply here by 2, and you multiply there by 2, this 2 cancels out, and you end up here with a 2, and then you can have x minus 2 squared minus 5 is equals to 0. If you check, our equation started with a 2. That was the value of a. Even on the original equation, you can see it from here. The 2 was the value of a, even from the original equation. So now from here, there are a few things we can get. We can get our vertex, and our vertex will be minus hk. So here, our minus h will be minus 2. So our vertex here is going to be 2, -5. And this is good because this helps you to sketch your graph, your quadratic graph. So this here, first of all, this is the vertex form. That is the vertex form. Now, these will be the coordinates of the vertex, such that if the graph, maybe let's assume it looks something like this. If you had a line of symmetry over here, if I was to find this coordinate here, this coordinate will be 2, -5. And same way, I can also get the equation for the line of symmetry. X is equals to +2. This will be the line of symmetry. Yeah, and that's how you go about such a question. You just need to be careful with how the equation looks like once you are done with it, because you'll need to be able to see these constants. All right, that's the end. I'll catch you up on the next video.